So we are going to learn how to do polynomial division, and there are two strategies. The first is long division, and the good news is that long division is very similar to, with polynomials is very similar to how you do it with integers. So the first thing I'm going to do is I'm going to write out my f of x part. So I'm dividing 3x to the fourth minus 5x cubed plus 4x minus 6 by x squared minus 3x plus 5. But I have to be very careful. I always want to include every single term that there is. And if there's not a term, for example, we don't have an x squared term, I want to include a 0x squared term so that I have a placeholder for that piece. And so I'm going to write that out here. Same thing with my other one. And so now I want to look and try to see about the biggest piece of each part of my problem. So for example, I first want to see about the biggest part of my, the highest exponent term of each of these. And I want to see what would I multiply x squared by to get 3x to the fourth. And so another way to say that is, what is 3x to the fourth divided by x squared? And the answer to that is 3x squared, right? 3x squared times x squared would give me 3x to the fourth. So I'm going to put that 3x squared right here over my x squared term. I always want to make sure that I'm staying in line with the terms that I have written out here. So if I have a squared term, it has to go over the squared term. If I had gotten something cubed, it would have gone over the cubed term. If I had gotten something over x, I would have put it over the linear term. So I want to make sure that I'm keeping them organized. And now what I'm going to do is I'm going to figure out what I get if I multiply 3x squared times this whole thing, x squared minus 3x plus 5. And so I'm going to do that. So 3x squared times x squared is 3x to the fourth. 3x squared times negative 3x is going to be negative 9x cubed. And 3x squared times 5 is going to be 15x squared. And just like regular long division, I'm going to subtract this whole thing away and write down what I have left. And so when I look at that, I have to be very, very careful with my negatives. So one strategy is to say, okay, I'm subtracting 3x squared. That means I'm adding 9x cubed and subtracting 15x squared. I think it's helpful to make sure you're keeping track of your negatives that way. And then I write down what I get. 3x to the fourth minus 3x to the fourth is going to cancel. That leaves me nothing, which is the goal. Negative 5x cubed plus 9x cubed is going to give me 4x cubed. And then 0x squared minus 15x squared is going to give me negative 15x squared. And then I want to make sure I carry down my other pieces. So I have plus 4x and minus 6. And now I'm going to start the process all over again. I'm going to say, what do I multiply x squared by to get 4x cubed? Or another way to say that is, what is 4x cubed divided by x squared? And we know that that would be 4x. And so I want to make sure that, again, I write that over my term that has just x. So that's a positive 4x that I'm writing in line with my x group. And so now I'm going to multiply 4x times this whole thing. So I'm going to start by 4x times x squared, then 4x times negative 3x, then 4x times 5. And so that gives me 4x cubed minus 12x squared plus 20x. And don't forget that I'm subtracting this whole thing. So I'm subtracting 4x cubed I'm subtracting 12x squared, which means I'm adding 12x squared. Sorry, subtracting negative 12x squared, which means I'm adding 12x squared. And then I'm subtracting 20x. So I'm subtracting each part. So my 4x cubed minus my 4x cubed cancels just like we want it to. My negative 15x squared plus 12x squared is negative 3x squared. My 4x minus 20x is negative 16x. And then I don't forget to bring down my negative 6. And now I am going to repeat this process again. So I'm going to say to myself, what do I multiply x squared by to get negative 3x squared? And the answer is negative 3, right? And I'm going to make sure I put that in line with my constant terms. And now I'm going to multiply negative 3 by this whole thing. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is positive 9x. And negative 3 times 15 is going to be negative 15. Or sorry, negative 3 times 5 is going to be negative 15. And don't forget that I'm subtracting this whole thing. So I'm subtracting 3x squared, I'm subtracting 9x, and I'm subtracting negative 15. So I'm being very cautious with my subtraction. And then I'm going to see what I get here. So my negative 3x squared and 3x squared will cancel just like we want them to. My negative 16x minus 9x will give me negative 25x. And my negative 6 plus 15 will give me plus 9. Now you'll notice we have no more spots left to put anything else. And that makes sense because now it no longer makes sense to say what does x squared multiply by to give us negative 25x. All of a sudden that's not going to be a regular term anymore. We're going to be dividing because x squared times something to give us x, we'd have to divide to get that. So that's our indication that we're done and we've gone as far as we can go here. And so what I'm going to do next is write out my answer. And so what this means is that this right here is my remainder. And so the way that I'm going to write my answer is by saying 3x squared plus 4x minus 3. That's all coming from this right here, right? When we divide this by x squared minus 3x plus 5, we get this with a remainder. And the way that we're going to write that is we're going to say we have a remainder of negative 25x plus 9 out of what we divided by. And so this whole thing is equivalent to when we said at the beginning that we were dividing this by this. So this expression right here is equivalent to this expression right here. This is our remainder, and we always are going to write it over what we were dividing by, that x squared minus 3x plus 5. So a couple things to note to be careful about when you're doing long division with polynomials. Anytime you're missing a term, like we didn't have an x squared term, we're going to put plus 0x squared as a placeholder because we have to keep them in order like this. We're going to start by dividing always the first term by the first term and putting that in the correct location, lined up correctly. We're going to multiply it out right here, and then we're going to subtract. And then we repeat that process until we run out of steps, right? Until we run out of spots. And then we see that x squared would not have multiplied into negative 25x. And that's how we know we've gotten to our remainder. Our remainder is always going to go above, in the numerator, above what we were dividing by. And that's our answer. So let's look at another example. Here's what I think you should do. I think you should pause this video and give it a try on your own. And then if you get stuck, start watching again. And then when you get the hang of it, pause it again and see if you can finish it on your own. So we are going to divide x cubed plus 5x squared minus 7x plus 2. And notice my terms were in descending order and there was no terms missing, so I didn't have to put a 0 in anywhere. And we're dividing by x minus 2. And so I'm going to start by saying, what do I multiply x by to get x cubed? And the answer to that is x squared. So I'm going to make sure I put that in the right location, above the x squared term. And now I'm going to multiply the x squared by x to get x cubed, and the x squared times the negative 2 to get negative 2x squared. And I'm going to subtract this whole thing, which means subtracting, and then subtracting a negative, which means adding. And so I'm going to go ahead and write down what I get. So these cancel. 5x squared plus 2x squared is 7x squared. And then I'm going to make sure I carry down negative 7x plus 2. Now I'm going to go ahead and do this again. X times what gives us 7x squared? And that's 7x, right? And 7x times x is 7x squared, just like we want it to be. And then 7x times negative 2 is negative 14x. And don't forget, I'm subtracting, so I'm going to say subtracting the 7x squared, subtracting the negative 14x means adding the 14x. My first term cancels. Negative 7x plus 14x is 7x. Carrying down the plus 2. And I'm going to do this again. What do I multiply x by to get 7x? And that's 7. So now I'm going to multiply it out. 7 times x is 7x. 7 times negative 2 is negative 14. And I have to make sure that remember that I'm subtracting this, right? The whole thing. My 7x minus 7x cancels. And then 2 plus 14 is 16. Now there's nothing for me to multiply x by to get 16. And I'm out of spots, so I know that that 16 is my remainder. And I'm going to go ahead and write my answer as x squared plus 7x plus 7 plus my remainder of 16 out of x minus 2. And that's my answer. So now we've learned how to use polynomial long division, and it's really important that we're able to do polynomial long division because we can only use this next type of division in certain circumstances, whereas polynomial long division we can use in any set of circumstances. But it is also nice to know synthetic division, which is what we're going to learn now, because it makes it a little bit faster and a little less tedious for certain problems. So we're only going to use synthetic division in the circumstance when we're dividing by x plus a number or x minus a number. We can't, and that has to be 1x, no other coefficient on x. So that's the only circumstance that we're going to use synthetic division. And so when we use synthetic division, we're actually going to make it a little more simple by going ahead and just utilizing the coefficients for now. And so when I do that, I'm going to start by writing out the coefficients of my f of x equals 2x cubed plus x squared minus 8x plus 5. Just like with long division, it's very important that if you're missing a term, that you go ahead and write a 0 there. However, in this one, we go from x cubed to x squared to x to the first to x to the 0, so we're not missing any, so we're good. So I took my coefficients 2, 1, -8, and 5. And I'm going to line them up in order. And then I'm going to draw a different kind of division bar, the synthetic division bar. And then I'm going to ask myself what I'm dividing by. And I'm dividing by x plus 3. And so the tricky thing here is that we are not going to write out the coefficients of what we're dividing by, but instead we're going to take x plus 3 and we're going to write out what we get when we set that equal to 0. So we get x equals -3, so that's the number that I'm going to put on the other side of our division bar. So it's very important that we put that in as the opposite of that constant term. So now we have -3 on the left, we have 2, 1, -8, and 5 on the right. And the very first thing we're always going to do is first carry down the first term. So the first term always comes straight down. And then what we're going to do is we're going to multiply 2 times -3, and whatever we get, we're going to put it right here. So 2 times -3 is -6. And then what we're going to do is we're going to add going straight down. So 1 plus -6 is -5. Okay? Now you have to be careful that you don't mistake this with our polynomial long division, because with long division we're subtracting, but with this we're adding. Okay, so then we're going to repeat that again. -5 times -3 is +15. And now we're going to add going down. -8 plus 15 is 7, +7. And then we're going to repeat that process again. And so we're going to say to ourselves, what is 7 times -3? And that's -21. And so I'm going to then add -21 plus 5, and that is -16. Now, then we have to interpret, what does this answer mean? So our final slot is always going to be the remainder, every time. And then you're just going to kind of count backwards. So what I mean by that is we have 7 is our constant, because that's going from right to left. Then we have -5x, because now we're going to increase our exponent by 1. And so that's our next term. And then we would have x squared. And our remainder, we always write over what we were dividing by. And that's our final answer. So people always find this part a little bit tricky, but I always start from the right and move this direction. So the first one is always our remainder. The next one is our constant. The next one goes with x. The next one with x squared. And if we had more, it would continue. X cubed, x to the 4th, etc. And so now we've divided. So you can see that this process is often a lot faster than using long division. But we can only use it when we have x plus something or x minus something. We can't have a coefficient other than 1 on that x, and it can't be x squared or x cubed. It's got to just be x plus something or x minus something. So let's do another example, and it would be great for you to give this a try on your own, but before you do that, let's just refresh on setting this up. So first I have x cubed, so I'm going to put a 1 for the coefficient of x cubed. Then I have 4x squared, and the coefficient is 4. But you have to be very careful because do you notice that we're missing the x term? So that means I have to put a 0, right? That's 4x squared plus 0x. And then minus 1. So you have to, just like with polynomial long division, you need to make sure you use that 0 placeholder. And then we're dividing this by x plus 3, which means we're putting negative 3 here. And so now we are going to go through our steps. 1 times negative 3 is negative 3. 4 plus negative 3 is 1. 1 times negative 3 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is 9. And negative 1 plus 9 is 8. So how do we write this as an answer? This is our remainder, so that's going to be 8 over x plus 3. Then we have our constant, right, which is negative 3. This is going to be our coefficient on x, and this is our coefficient on x squared. And so this is our final answer.